Good morning. Today we will learn about the thermal energy storage. Like any other energy, thermal energy also need to be stored because whenever energy is converted into thermal energy, probably at that time the requirement of energy may not be that much uh, to the extent it is produced. So we need to find some technique to store it. There are different way of storing it. There are three types of thermal energy storage systems are there. First one is sensible heat storage. Results in an increase or decrease of the storage material temperature. By increasing the temperature of the material or decreasing the temperature, energy is stored. Stored energy is proportional to the temperature difference of the used material. A second method is latent heat storage. It is connected with the phase transformation of the storage material. Temperature of the material will not change. The phase of the material might change. Typically changing their physical phase from solid to liquid and vice versa. So when a material changes from solid to liquid form, it absorbs thermal energy, heat, but temperature will not rise. Instead it will change the phase of the material, transformed into another uh, phase. Uh, Thereby, by transforming the phase, energy is stored. This is the second method, which is called as latent heat storage technique. There is a third method using the thermochemical heat storage. It is based on the reversible thermochemical reactions. There are two types of reactions are there, endothermic and exothermic. The energy is stored in the form of chemical compound created by an endothermic reaction, and it is recovered again by recombining the compound in an exothermic reaction. So in an endothermic reaction, heat energy is stored, and if you want to retrieve it back, during the exothermic reaction, it is released. Uh, the integration of thermal energy storage in solar thermal system has significant benefit. Why we need to store it? The solar contribution is increased and the thermal energy storage allows the operation during times of non-solar radiation. It is one advantage. Secondly, rapid flux variation can be compensated, which increase the lifetime of the component. Third one is surplus energy can be used and does not need to be dumped. Fourth advantage is the size of the subsequent component, that is evaporator, condenser, boiler, turbines can be reduced. Otherwise, too much heat is there, thermal energy is there, that much big uh, condenser, boiler, etc. will be needed to use it. So, since it is stored, so entire energy is not used at the same time. So the size can be reduced. Thermal energy storage allows thermal management of the solar system. Uh, so it can be used to cover peak demand. Normally, the stored energy it can be, for example, for the power requirement, the peak load to meet the peak load during the evening time in the power system. This thermal energy can be used to meet the traditional power requirement. Uh, So summarizing it, this slide we can see thermal energy storage three types: sensible heat, latent heat, chemical heat. Sensible heat, so it can be solid, liquid, or a solid liquid combination, which by raising its temperature store the energy. Latent heat, whereby change of phase energy is stored. In chemical, during the exothermic reaction, energy stored, endothermic reaction energy stored, and exothermic reaction it is released. These are the methods by which energy can be stored. Thermal energy can